Here's another complex fraction example. Simplify. X squared minus 5x plus 6 over 5x squared y divided by x squared minus 9 over 5x squared y. So this one's a little more complicated than some of the other ones we've been doing because we have to factor first. Okay, so we're going to look at this. This is the vinculum. And I want you to look at the numerator here and then look at the denominator. We need to get each piece into a product. So instead of x squared minus 5x plus 6, it would be really nice if we had two or three things multiplied together. Same thing down here. Instead of x squared minus 9, it would be nice if we had something times something else. And we can do that by factoring. So we're going to go over here and we're going to do some factoring. So we're going to factor x squared minus 5x plus 6. So there's several different ways to do this. I want to point out a couple of things. Remember, this last sign here, positive sign here, tells us a few things. Tells us signs, when we get done in our parentheses, are the same. Okay, it tells us not only are they the same, we're going to use the middle sign. That last sign, positive, also tells us that we are going to add factors to get negative 5, to get negative 5. So let's look at the factors of 6. Notice the lead coefficient here is a 1, and we're looking at 6. We're always looking at the front and the back. So factors of 1 are 1 and 1. Factors of 6 are 1 and 6 and 2 and 3. So we're going to use a 1 and a 1. But then we want factors that add to get negative 5. It tells us signs are going to be the same in the parentheses. And we're going to use the middle sign. So this means my signs are both going to be negative because that's the middle sign. So if you're going to add these, what's negative 1 plus a negative 6? That's negative 7. What's negative 2 plus a negative 3? Negative 5. So you're going to use this combination. Okay. So if you have x squared minus 5x plus 6, one way to do this is say, well, these are going to be the numbers in the back since your lead coefficient was 1. X minus 2 times x minus 3. I'm also going to show you how to do this by grouping in case some of you factor it that way. Or x squared minus 5x plus 6. Again, we're going to use the same thing. We're going to look at factors of 6, 1 and 6, 2 and 3. We still want them to add to negative 5. Use the same sign as the second term. So we put minuses here. Which of these, when you combine them, give you negative 5? This set. So we're going to rewrite this piece right here in terms of negative 2 and negative 3. X squared minus 2x minus 3x plus 6. Check it. Negative 2x minus 3x is negative 5x. Okay, so now we're going to factor by grouping. So we're going to group the first together, first two terms, and then the last two terms. What do the first two terms have in common? X squared minus 2x. They both have an x in common. That is the greatest common factor of those two terms. And then we say, well, x times what gives me x squared? You need another x. And then x times what gives me negative 2x? And negative 2. Then we do the same thing, two terms in the back. The trick here, though, is we'd like whatever's left over to be the same as what we had in the first set, x minus 2. So negative 3x plus 6, what is the greatest common factor in these terms? Start with the numbers. Well, 3 and 6 both have a 3 in common. So we're going to put a 3 here. You may be tempted to put plus 3. You'd say 3 times what gives me negative 3x? That means you'd need a negative x. Then you'd say 3 times what gives me positive 6? You would do a plus 2. But then you'd say, oh, I wanted these to match because you're hoping to combine further, right? So you say, if something's wrong, I'm off by a negative sign for both. The sign is backwards. So instead of factoring out a positive 3, you would factor out a negative 3. You say negative 3 times what gives me negative 3x? Well, you're missing the x. Negative 3 times what gives me positive 6? So a negative times a negative is a positive. So I'm missing a negative 2. They both have an x minus 2 in common. So we can say this is x minus 2 times x minus 3. Or, if you do it in the other order, x minus 3 times x minus 2. That is the commutative property. A times b is the same as b times a if we're looking at the real numbers. Okay, so that's how I factor that part. I also need to factor x squared minus 9. So let's do that over here. First question you always ask is, do these two pieces, x squared and 9, have anything in common, any greatest common factor? No. So then you say, well, how many terms are there? There's 2 terms. The next question is, are they written in terms of descending powers of the variable? Yes. Okay, so if there's 2 terms and they're written in descending order, is there a minus in the middle? Yeah, there is. Okay, so let's see if this is a difference of 2 squares. Is there something I can square to get x squared? Yes, I can square an x. Is there something I can square to get 9? Yeah, 3 squared is 9. I'm going to put a 3 in the front, a 3 in the back. You put a plus in one and a minus in the other. Again, if I write them in the other order, x minus 3 times x plus 3, I do get the same thing. Okay, so now we're going to go back to the original problem and we're going to factor those parts. So instead of x squared minus 5x plus 6, we are going to write x minus 2 times x minus 3. All of that is still over 5x squared y, one big vinculum. Instead of x squared minus 9, we're going to write that as x plus 3 times x minus 3. All of that is still over 5x squared y. So we're going to do this in 2 ways. I'm going to give you 2 choices. The first thing to do is to look at the numerators and rewrite it. So if you can have a fraction divided by a fraction, you rewrite the numerator. And then you multiply by the reciprocal of the denominator, which means we would multiply by 5x squared y over x plus 3 times x minus 3. Notice there's a 5 in the numerator and denominator. There's an x squared in the numerator and denominator, and there's a y. Those cancel. Oh, look, there's an x minus 3 in both pieces as well. So it looks like my answer is x minus 2 over x plus 3. There is another way of doing this. I'm going to go ahead and do it down here. So all I've done so far is just rewrite the problem. Looking at the numerator, looking at the denominator, I can multiply the top and the bottom by the same thing, by the number 1, to clear the denominators. If you notice, they both have a 5x squared y. So I can multiply this by 5x squared y over 1 divided by 5x squared y over 1. I'm multiplying by the same thing over itself, so I'm multiplying by the number 1. I'm not changing my expression. When you do that, you see 5x squared y cancels because there's 1 in the numerator and denominator. Same thing down here. So you end up with x minus 2 times x minus 3 divided by x plus 3 times x minus 3. Looking there, we can simplify. You have an x minus 3 in the numerator and in the denominator. So this is x minus 2 over x plus 3. And that's the same thing we got before, just a different way of doing it.